This video is based on improved grasshopper optimization algorithm. In this video, we will try to understand how this algorithm is working step by step. Basic grasshopper optimization algorithm and hybrid grasshopper optimization algorithm we already discussed in the previous videos. For more details, you can check the link given below in the description box or in the comment section. In this video, we will try to understand how improved grasshopper optimization algorithm is working, and for better understanding, we will compare the mathematical models used in basic grasshopper optimization algorithm and in the improved grasshopper optimization algorithm so that we can easily understand how this algorithm is working. First of all, as you can see here, improved grasshopper optimization algorithm is introduced in 2021 by Peng and al. For more details, you can check the research paper. As we already discussed, grasshopper optimization algorithm is basically inspired by the grasshopper swarm behavior in the real life. So this algorithm mimics the grasshopper's behavior in nature. And this algorithm is tested on different benchmark test functions including unimodal, multimodal, and composite test functions. We can use this algorithm to solve different constraint engineering optimization problems, clustering problems, feature selection problems, economic load dispatch problems in power systems, and other. In this video, we will try to understand how improved grasshopper optimization algorithm is working. In basic GOA, agent's final position is updated using its current position and global best position. In improved GOA, you can see here velocity is calculated, gravity force is also calculated, and then the agent's position is updated by adding velocity in the updated position. As you can see here, in the current position we are adding here velocity. So in improved grasshopper optimization algorithm, gravity force is calculated. In basic GOA, gravity force is not used to update the final position. So here in improved GOA, we will calculate the velocity and the gravity force for each grasshopper. In basic GOA, you can see here the parameter used, that is adaptive parameter C, and here in improved GOA, you can see here we are calculating the gravity force. So here we have gravitational constant G, acceleration coefficient A, and we have adaptive parameter C. And value for A is 2, G is 0.9. For better understanding, first we will try to understand the mathematical models used in basic GOA. Here, Xi denotes the grasshopper position in the search space, Si denotes the grasshopper social interaction, Gi denotes the gravity force, and Ai is the wind advection, and I denotes the total number of search agents in the search space. For grasshopper random behavior simulation in the search space, random values are used. Here you can see R1, R2, R3. They are the random values normally distributed within 0 and 1. So here we are adding the randomness in the grasshopper swarm behavior using random values. Next, you can see here the social interaction calculated using this equation. Here Si denotes the grasshopper social interaction, and here I denotes the number of grasshopper, where I is 1 to n, n is the total number of agents in the search space, and S represents the social force, and here this is the Euclidean distance between two grasshoppers, and this is the unit vector. Now one by one we will calculate the values for social force, unit vector, and Euclidean distance. So the Euclidean distance between the grasshopper I and grasshopper J is calculated as xj minus xi, xj that is the jth grasshopper minus xi that is the ith grasshopper. And next you can see here unit vector calculation. Unit vector is also known as direction vector. That is the vector quantity having both direction and magnitude. And you can see the unit vector formula here. Unit vector is equal to vector divided by vector magnitude. Here you can see the unit vector from grasshopper I to grasshopper j is calculated as vector divided by vector magnitude. Next we have social force. Social interaction between grasshopper is defined as attraction and repulsion. Attraction increases in interval of 2.079 to 4, then it gradually decreasing, and for repulsion range is 2.079, and when there is no force it means there is neither attraction nor repulsion. This is known as grasshopper comfort zone. And here using this we can calculate the social force between grasshoppers. Here this is the attraction intensity and this is the attraction length. After social interaction we have gravity force, and we can calculate gravity force using this equation. Here G denote gravity for ith grasshopper, and this is the gravitational constant, and here again this is the unit vector towards the center of earth. Next we have wind advection calculation, and here A denotes the wind advection and U is the drift constant, and this is again the unit vector in wind direction. Now we will substitute the value of S, G, A in this model, and here you can see xi, that is the grasshopper position, and here you can see the value for Si, and this is the value for Gi, and here value for Ai. Now you can see here this is the final equation we obtained for agent position, but we cannot use this equation to solve optimization problems. As we will use this equation, grasshopper will reach in their comfort zone and they will not find out any target solution. So here you can see the enhanced version for this equation. Here C is the Bate inertia and C max is the maximum value of C. C min is the minimum value of C, upper bound, lower bound in the dth dimension, and here you can see this is the global solution. So the final position update in the basic GOA is done based on its current position, global best position, and the position of other grasshoppers. In improved grasshopper optimization algorithm, gravity force is considered. In the basic GOA, gravity force is not considered, but in improved GOA, gravity force is considered, and you can see here gravity force is added, and this is the, so here you can see in this equation gravity force is added, and the velocity for each grasshopper is also calculated in improved GOA, and then the final position is updated for grasshopper in improved GOA is done using this equation. Here this is the current position in the dth dimension plus velocity. We added here velocity. Here A is the acceleration coefficient and rand is any random value that is normally distributed, and this is the target solution, and this is the current position. In improved GOA, the final position update is done. Here we will check the probability. If this condition is true, we will update using this equation, else we will update using this equation. So first we will initialize the population randomly in the search space and also initialize all the important parameters like population size, maximum number of iteration, acceleration due to gravity, and other parameters. Then we will compute the fitness value for each agent in the search space. After that, update the parameters and then update agent's position in the current population. After that, for the updated solution, again calculate the fitness values and then check the stopping condition. If the stopping criteria is met, then stop and display the optimal solution obtained in the previous iteration, else we will repeat this loop until the stopping criteria is met. So that's all about this video. In improved GOA, gravity force is considered and final position is updated using gravity force, and in basic GOA gravity force is not considered. So that's the difference. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.